All right, we're going to go ahead and get everything kicked off. Good morning, good afternoon, everyone. I'm Jason Johnson with NCLUG, and welcome to today's NCLUG Tech Talk from Kimley-Horn and Associates. Today's webinar will be on roundabout design with intent using open roads technology. But first, a few details before we get started. The webinar is a presentation, so all attendees will be muted. At any time during the webinar, you can submit your questions into the chat box. As time allows, our presenter will address as many questions as possible during the Q&A session at the end of the presentation. We will be recording this webinar and will share the link after the event. NCLUG is offering PDH credits to those who have registered on the website for this event. If you're afforded the meeting link, you will need to make certain you're registered on the nclug.com website. After this session, NCLUG will send out PDH receipts to those who attended this live meeting. Credit will not be given to those who view the recorded presentation. As of this meeting, PDH receipts have been sent out through October 14th, our October 14th Tech Talk. We will be holding a drawing for a $50 gift card at the conclusion of this presentation. Now I'd like to introduce Mike Donahue, a buddy of mine and project manager associates, as our presenter today. Go ahead, Mike. Thanks.
Thank you very much, Jason. Again, my name is Mike Donahue. I am based out of the Sarasota office of Kimley-Horn and Associates in sunny Florida. And today I'm going to do a demonstration of roundabout layout. I know in the Tech Talk narrative, it said it was going to be a single lane roundabout. I decided to go ahead and try and do partial 2-lane, so a 2x1 roundabout, just to further demonstrate the technology. I wanted this to be as organic as possible, so I did not do a lot of presentation rehearsal in order to do this, because I really wanted to show people how to think with the software on the fly. Now, this is based off of a lot of experience using the software. The software that I'm using is the FDOT's Workspace on the Select Series 4 platform. So I'm running the FDOT SS10 Workspace. Again, I work out of Florida, so we stay in step with the FDOT on their software development. We will be moving to ORD in January of next year for all new contracts with the FDOT. But I did want to use this platform because I'm not as versed just yet with the ORD. And a lot of these tools that we're going to use today, the civil tools that are found in SS4, do carry forward into the ORD platform, although the interface is a little bit different. It's more of a ribbon-based interface. So these are the tools that we're going to be utilizing today. We're going to focus mostly on the horizontal geometry. We won't be looking at vertical or anything like that today. I will utilize, however, a lot of the feature definitions that are provided by the DOT. It's more of a force of habit than anything else. This will replace the usage of a standard level symbology. It will apply level symbology to it, but I'll just use that pull down to access some of the features that FDOT has provided with their workspace. So with that, I'll go ahead and get started. Essentially, what I'm going to do at this intersection is I'm going to provide a north and south corridor that has a 2-lane approach and a 2-lane exit, and a single lane approach and exit in the east-west condition. Now I'll start off by just drawing my inscribed circle. And again, I'm just going to kind of eyeball some points here initially. And I'll give it a 90-foot inscribed radius, which is 180 diameter. And I'm going to offset this element to provide for 2 14-foot lanes. The design intent is built into using the civil tools. So I'm going to talk a little bit about that as I go, but it's really more of a demonstration than to try and tutor you up on how to use every piece of the tools that are available. So the intent shows on screen what my dimensions are. And as I build other elements into the roundabout, the design intention, essentially the software is going to remember what my intention was, whether it was a radius and what the radius between the two elements was from a value perspective, whether I intended to trim ahead or back of the radius, and things of that nature. So I'll start off by just establishing a little bit of a lane here. I'm going to turn off my AccuDraw. That's another thing, little tidbits as I go. This toggle AccuSnap, I would have that turned off when you're using this software. A lot of the times, if it's trying to jump and snap to different elements, depending on what your snap is set to, it can actually freeze you up and sometimes even kick you out of the software. So I try and avoid using that, and I often don't use my AccuDraw. So based on this line, again, you see the intelligence that's built into it. It's a civil element. It has a begin and an end with a bearing and a distance. And I can move this element around. I can change the angle of it pretty quick and easy. I can keep the angle and extend it forward and back by using the arrows and these points. I can keep the angle and change the offset of it as well. And I'm going to add an arc from the element, because I know I want to come in a little left of center on a roundabout. Give it a 400-foot radius. And this is where the intelligence comes in again. I'm going to tell it I could either trim back. If there was another element here, I could trim ahead. Since this was the element that I selected at first, that will be back of this element. And so I will select the trim it. This is a parent element. This is a child of the parent. So if I select this element, you see the truncated portion, but there is still the original element recognized by the software. So I could grab this and change angle of that element, and it will hold this relationship. I can change the beginning point of this arc, and it will hold the tangent relationship to that horizontal element and pull it back. And it'll remember that there was a trim associated at the back location of that radius. So that's how you can kind of see the power of this software as you move forward. And I'll draw a simple line to element from the arc. This is a little backwards from where I want it to be. So as I'm wiggling around, if I just hit the Alt button, it'll flip the direction. And again, I want to come in off center, and I want to trim to the back. So now I have a tangent, and I have an arc, and I have a tangent that are built with the relationships that I created them with. So if I take this arc and I move it in, you can see it's holding this endpoint, but it's maintaining a tangential relationship to the radius. If I take this endpoint and I move it, it's going to hold that tangential relationship and alter the geometry based off those relationships. This is going to be a single lane entry, so I'm just going to add a simple arc between elements from here to this outside lane for now. And again, I don't want to trim both because I want to keep the integrity of this inside lane because I'm going to use it multiple times. So I'm just going to change this to a back trim. That is something that I can change in the future, by the way. I can come back into the properties of that element, and I can change the trim from back to ahead or to both, and it'll remember that moving forward. And it looks like I may have just froze. Nope, there we go. So the relationships are still constructed. So if I move this tangent, I'm now altering all of the elements connecting to it as well. And this is my offset, single offset. Anytime you see a little black triangle in the corner, if you hold down your left click, you'll see the other options available. You can do partial offset of an element. I'm going to offset the full element because I want to demonstrate that this offsets the parent element, not the child. So it's not actually offsetting the truncated element. It's going to offset the entire element that's underneath. So there's a little cleanup work associated with it. And you can use regular microstation trim to intersection to clean those up. And that is creating a relationship that's also remembered. So these are built 12 feet off of the center line, all of these. So if I change any part of those parent elements, you can see it's maintaining that offset, and it's remembering that I trimmed to intersect these as well. So in a roundabout, I know I want a little bit more width on my entry here. So what I like to do is I'll create some guidelines for myself as I go. Using, let's say this one should be easy enough to see. Using some construction class elements in the features, I'm just going to draw a line from the intersection of my entry radius to my inscribed. And I want a 15-foot width at a minimum, and I'll snap to the center point of that arc so that I know that that line is now perpendicular. And you see these symbols here on screen. Maybe if I take my aerial, turn it off, you can see that better. This is letting you know the relationship that this line was built with from a snap perspective. So I'm building this with an intersection relationship here and to the center point here, and you see that my distance can be changed at any time, and it'll still hold those other two. Looks like I lost my center point. There's always going to be one of those errors. So let's do that again. And then once that's out of the way, we can move on. So again, you see the relationships there. Now what that does is if I end up changing this radius to something smaller, it's holding that intersection relationship and going to the center, so I know it's still perpendicular. And that provides me with a decent guideline for when I come back and add this outside radius. Now it's remembering the last radius value that I keyed in, but if I hit the end button on my keyboard or I unlock it by unchecking this box on screen, then I have a dynamic radius that I can kind of see the results of as I go. If I snap to that endpoint, I can see it's defaulting to 99.4. I'll just round up to 100. And I only want to trim the back relationship, not the ahead and back relationship. Turn my aerial back on. So now I have one approach sketched up. And again, this is just a sketch at this point. I haven't vetted it for speeds or swept path or anything like that. And once I do, I'll be able to quickly and easily change some of these dynamics to see the results on the fly. And I'm going to add my 2-lane entry. I'm going to make the assumption here. And I'll just hold that existing geometry initially. Scoot this back a little. This is going to be a little higher speed, I think. So I'll start my radius on this element. See if I can avoid this driveway. Let's see what that does. Is that going to be left of center? Probably not where I want it to be, but we can change that. And it's going to be the same process over and over. I always choose the wrong one. There we go. Again, I'll have to flip this. And I'm going to come in left of center. Just not going to do. Another way to help visualize whether you're left of center is to add another circle from the center point. Half lane width or something to that effect. So I know I'm coming right of center on this roundabout. So what I'll do is I'll pull this back. And then I'll change my tangent. And the reason that I'm doing that is I know I want at least 50 feet of tangent here before I begin my entry radius. So I'll rotate a little bit, make that easier to see. One of the ways I like to check that on the fly, again, is I'll use a construction class element and I'll draw an arc. And you can choose from different ways of applying this. For this, I'm going to use a center radius. Left click to accept that, and then snap to the center of where that wants to be. And if I want a minimum of 50-foot tangent, then I'm just going to demarcate that on here with a guideline. And that'll come into play in a second. Multi-lane roundabout, I would like to come in tangent to this inside. And I'm just going to throw this out. Again, I don't have to be too cautious, and I do not want to trim back. Again, I want to maintain the integrity of that interior element. So I'm just going to right click to keep that without any trimming. And then I'll add a simple arc between the two elements, and I'll hold that as 100. And this time I'm going to trim both. So I know I have a minimum of 50-foot tangent here, but if I change this, I'll be able to kind of see when I violate that pretty easily. And again, this is something I can change if I wanted to extend that to an 80-foot. I can change those guides on those values on the fly and see what the impacts of my decisions are as I'm laying out the geometry. And as I change any of these elements, all the relationships are being held And you can see that's looking pretty good. So I'm going to hold it for now. Using my single offset, excuse me. Just going to add my lanes for a dual lane entry. And then I'll clean these up. I got muted for a second. Sorry about that. So I'm going to hold the 12-foot lane widths all the way up into the back point of this radius. For this, there's a couple ways to do that on a multi-lane roundabout. Again, I know this is not intended to teach roundabout design, but a lot of times you're going to have a gored area in between, depending on the tractor trailers that you're going to have coming through a roundabout. I know that this corridor does have heavy truck traffic on it, so I would probably go with a case 2 or case 1 if possible. So I would offset this only the 12 foot, which is less than what I'm seeing here. And I'll go ahead and offset the inside as well and clean that up. But I'm going to want a gore area between the lanes in order to provide some overtracking by the tractor trailer on the inside lane. The way that I like to do that is I'll just offset this line again another 3 feet or so, depending on what the gore width is. And again, that's flexible because now you have these dimensions you can always change. And I will create a simple arc between elements that matches the other one. And I want to trim to the back, not to the front. And then I'll offset these a lane width as well. Oh, that won't work there, but trim this up. And this is a pretty cool tool. This line between arcs allows you to trim ahead and back with an offset from the arc element. So I typically have that set to 0. You pick the beginning element. This is to establish the offset, not actually on the element where you're beginning. So as long as you key in that value, it's okay. You can have it as 0. And you can see what it's doing. It's drawing tangent to tangent. And there's no back length. And I'm going to trim to the back. I do not want to trim the outside edge. So now I have another approach established. And I would want to offset probably my median. Give this, let's make it 6 feet wide. See if we can use an arc to arc. That doesn't always play very nice, but we'll see. And we'll turn this off. Yeah, it's going to play nice. Good. This is going to be more of a tangential exit. So let's say 550. And we'll trim back. Offset that 12 feet again. 2 lanes. So I know at this point here, I want to be 12 feet across for each lane. So this is where I want to be. And I'll allow my transition to the 14-foot width to occur from this point tangential to the lane lines within my roundabout. And again, I like to use guides to let me know where I'm at. So I'll draw from this point over 24 feet to the center of that arc. And then as I place these radii, getting a lot of feedback. You can see I can shorten this up a little bit and still be 24 feet across at that location. So if I hit the end button on my keyboard, I can dynamically kind of scale this. So let's try it at I like 515. And I'm just across that line, so I know that'll work. And I'll do the same on this side. That doesn't have to be that long. So I can tighten that up a little. So let's call it 25. Whoops. No, 490. Probably go less, 480. That'll work. So in looking at this, I have 2 approaches generally laid out. I know that this is going to be a bit of a challenge, right? That's pretty acute. So this is likely going to be pulling out and coming in at a tighter angle left of center. So I'm going to try and capitalize on the existing geometry over here. One of the ways I would do that is by tracing the edge of pavement line, offsetting that. I think those are 12-foot lanes. Yeah, it looks pretty good. Can always move this a little bit if you're wanting to be sure. And I'll draw these. That's not quite where I want it. I'll draw these again just to try and mimic the existing so I can establish the geometry I'm looking for. I'll offset this as well. I know I want, again, a certain length of tangent here. And now I'm going to switch over from drawing on the outside. I'm going to use this offset element on the inside. And I will first establish a guide. Let's do it that way. I haven't done this yet. So I want a 100-foot tangent for this. Come on, there we go. Go back to using my lane line. We'll try that for now. And I trimmed that back, so I'm going to redo this. Wasn't sure how that would play out. So you can see it's a lot of the same over and over. But I do want to get through at least a good portion of the rest of the roundabout because I want to show you how you strip all this intelligence back off of the line work and reduce it down to just general CAD line work for the use of plans production or taking this and furthering it. And the reason for that is a lot of the trimming and the offsetting that you see in this environment, you get kind of a diminishing return on the effort that it takes to produce it. So a lot of the times when you're laying this out, it's just better to focus on using the lane lines to establish the geometry and then kind of abandon this environment and go back to CAD, at least until the ORD is more fully established and you're using it for full-blown design. I'm going to move this to an intersection here and here. And create a entry. So I know I definitely have 50 feet here, so I'm good. Go ahead and offset 12 everywhere. Clean it up. Draw another guide for my width on entry. Add this radius. This time I'm going to snap to the end of that line and just let it be kind of an odd radius and show that you can build that relationship as well. You see that this has been snapped. So if I end up changing this radius to 90, for example, this is dynamic now. So this value is dependent on tangent to this line, tangent to this arc, and matching exactly 15 feet at that location. So that's another way that you can build these relationships in. And it may be hard to keep track of them at times, you know, not knowing exactly what you built into what element. You can always color code them if one is governing over the other, for example. So there's always the possibility of doing it that way. This may be a challenging corner right here because it may be too acute. So this is my eastbound lane. And I'm going to try and come from, I know I'm probably going to take this left turn and ultimately I'm probably going to move him out a bit, but I want to be able to turn from probably from here. So I'll take it from here initially. Yeah, it's going to be, oops, wrong lane. That's going to be interesting. Be good to show, again, I don't want any trimming there, but that's going to be, it'll be a good exercise to show the flexibility of doing design this way. Because I'm not real fond of how tight this is in this corner right now. And I know that just from criteria, I know I usually want to have whatever this arc is between these two. I don't want to exceed a 3-foot offset from my inscribed, kind of a industry standard. So if I offset a guide from my inscribed and then try and add a radius between these, call it a 50-footer, you see that I'm violating that distance. So at this point, you have a couple options. You could try grabbing the center island or the inscribed of your roundabout and moving it into that to kind of reduce that width. Getting closer. You can also increase the size of your roundabout. That helps. But this is the dynamic function of the software and how it really helps reduce the rework associated with vetting a roundabout. But you do have to come back in and check, am I still off center to the left? Do I still have the proper deflection coming in? That's off center. That looks off center. This is off center. So for now, I would probably leave this the way it is and move on to establishing the remainder of my geometry. And then after that, of course, there's all the performance checks that goes with roundabout design. So let's see if we can, I don't want to do it that way. I don't want to snap to that endpoint in case I extend that endpoint. I can demonstrate that real quick. So if I try and use some of the existing geometry here, and then later on I want to take this line and use it for my exit path, which I got a feeling I'm gonna, and I try and extend this, what happens is the endpoint of this line was built with that snap relationship. So it's going to change this geometry. And you can see if I had my entire approach already constructed with those relationships, and then I extended this line, it would change this tangent, which would change the arc, and it would ripple through. So there is a little bit of risk associated with building some relationships, but I don't really want to do that. So I'm going to break that relationship. And I'll extend this past it. Come on. Got the arrow. Try a, gonna eyeball some stuff here. Put this in. No, I don't like that. That looks better. Jump to the back. Draw a tangent. Flip it around. Come in left of center. Now this may end up being too short, so I may have to make some changes. So we'll see. Just quickly check it. 68.56. That looks good for now. Go ahead and add a check and a balance just in case. I have a feeling I'm going to have to make some changes. These are always good so that when you are changing geometry because of your performance, the roundabout performance, you're always going to be able to tell whether you're violating that minimum 50-foot tangent that you really want. And I actually went directly into this, so that's a mistake. So I'm going to back out and just delete that radius, and it'll return this element back to its parent, its full parent. So I want to come off tangent to this line. Oops. Let me change my feature back. No trimming. I'm going to add an arc at 100 feet now. Now trim both. So I know I have length here, but I'm going to want to tighten this up probably a little bit. I kind of try and target that second lane for the end of this guy. And it's going to be much of the same approach to the entry geometry that you saw on the other side. And for the sake of time, I won't ripple this all the way back because I want to demonstrate once I have this set up. You know what I can do? I can show, if you don't have the gore area, I can show exactly how I would do that. So let me back out of these. And I'll offset the lane 12 feet and the arc 12 feet. And if I wasn't going to provide the gore area from a striping perspective, then I would do a line between arcs with a 0 offset from this line to the target entry lane in the roundabout and trim it to the back. And then I would offset it again 12 feet for the outside lane and do the same for that outside. And back. Yeah. And now we'll look at the exit movement. Again, the exit's going to likely come off of this left turn that's going to spiral just a little. It's not going to be a true spiral in the sense that I won't bring it out here and push the whole roundabout out. You can absorb that in the island, and I'm 12:30. I should have time to show you how to do that. So, and I don't do that really in this environment. It doesn't have to be, you can, but I want to show how you export this and clean it up pretty quick once you're happy with the concept. So I'm just going to take this from this inside lane, or take it from the outside to here. I don't want to get into the bridge. I know it's just a concept. So 360, let's try that. And I know that I started here, so if I do back or both, it's going to cut this line off. And so I'm going to hit A to change it to ahead. I want to trim to the ahead. Oops, I didn't really want that because I did want that line to continue on to here. So what I can do is grab this, go in and change this to none. And then you'll see it'll revert it back to the previous relationship. And I'll offset this 12 feet. And if I put in a radius between these two, it's probably going to look pretty good. Try 50 feet and go 65 there. And I'll trim both on that. So the bulk of the geometry is there. It looks like adding a little bit of diameter rather to the inscribed. I'm resolving some of this acute turning movement here. You won't really know until you run your fastest path whether you have to make an adjustment. If so, it may just be a matter of grabbing your roundabout and increasing the size. You know, obviously it depends on whether or not you're allowed to have a lot of right-of-way impacts. So, and everything that you do, you can tend to undo with the regular microstation command. That's always helpful to know. And I'll draw this guy up to inside to here. And let's try 450. Trim ahead. And I'm going to draw another guideline. I know I want a minimum of 6 foot of width here. So I'm just going to do a single offset partial of this parent element from this endpoint to this endpoint. And I know it's on the wrong side. That's easy enough because I'm going to change this to a +6 and it'll jump to the other side. So as long as I'm not coming past that point, I know I've met my minimum width, desired width rather, for the median. And I will offset this as well, 12 feet, 12 feet. So this is interesting to show. So this element, again, it's the parent element stops at this dot. This is the end of the parent element. And when I trimmed it back, it extended the element to the beginning of the arc. But this is the child, even though the child is longer than the parent. So if I'm going to offset this element, I won't be able to offset it from the portion of the element that's the child. I have to actually go to the parent element and offset it. And you see it only offsets the length of the actual parent element. I can always grab this and use the arrow to pull this longer, and it'll extend the offsetted element as well to mimic the length of the parent. And then clean up the line work a little bit. And I can always clean this up a little. Or I could always do the same thing I did before and draw a guide right here and then change this radius so it's tangent to tangent, tangent to tangent. So it is 12:38, and I would like to show now just how to clean this up and get rid of some of this intelligence, right? So you have a roundabout laid out, you have all the intelligence built into the line work. So if your fastest path is not giving you the results that you want at any given entry point or exit point for that matter, or your path overlap is not working out for you, you can do all that in this file or come back into this file and make a change, whether it's dynamically changing the overall size of the roundabout or some of the entry links or angles. If your speed's pretty slow here, you may want to flatten this out a little bit and check it again and see if it's still within tolerance. But doing it this way is going to save you from a lot of deleting and redrawing of elements as you go through performance vetting. And that's really the idea behind leveraging this technology to set all that up. But once you have that technology, offsetting curb and gutter lines and drawing up your sidewalk and all those things can become very cumbersome and time consuming using these elements, because just offsetting this line with a microstation command to move parallel or copy parallel, it doesn't work. It doesn't recognize it as a standard microstation line. So you're not going to be able to just offset these for 1.5 feet for a face of curb line or 2 feet for a back of curb line. And if you use this element to do that, then you're going to get the parent element, right? So offsetting this 1.5 feet everywhere, you'd have to come back in and trim it everywhere. Where with microstation line work, we know it would only come to this point. That would be the extent of the element that's offsetted. So that's why I say there's diminishing return to using this to finish the product, at least from a roundabout perspective. Once you have a roundabout that you're comfortable with the geometry, the best way to do that is draw a fence around your elements and do a file fence, copy move fence contents to file, and give it a new file name that you plan on using for production, and export the line work. Once you have that line work exported, of course, it's going to strip out the aerial, but that's neither here nor there. What you'll want to do is, as soon as you get into the file, just grab everything and drop all your element line strings. And that will dumb it down essentially to just basic microstation line work. And I'm sorry, but the dash lines drive me nuts at this stage. So I'm going to change it. And then all you really have to do is a little bit of cleanup work from an entry exit standpoint. Like I said, this area in here, you're really going to only have probably one lane exiting. So one of the ways you can do that is, at least one of the ways I like to do it, is I'll set I'm using already a different level. So back to using microstation lines instead. You can draw a tangent to this element. Start in mid. Tangent to this line, come off tangent to your exit line, and begin at roughly where this median nose is going to be. And again, I'm not going to drown in a drop of water and try and make this absolutely perfect for this demo. Although that's a little annoying, so I'll fix that. Tangent to tangent. That looks close enough. And then you're going to be cleaning up some line work. Right. And then this guy, shorten up. Exiting here. This one's exiting here. This will look like this. This will be your median. This guy goes away. This guy gets trimmed up. He'll be on the outside. Match some of this. And again, now you're just using regular MicroStation to clean everything up. So sorry about that. You can tell I don't use regular MicroStation so much anymore. There you go. And then you walk that around. And before you know it, you have that repeated all the way around and have a nice clean roundabout concept to work with. So with that, I don't know. I haven't been keeping up with whether or not there are questions, Jason. That went a little bit fast, which is fine with me.
Yeah, we got a few questions, and I'm sure there will be more, but I can go ahead and run through a few of them if that works for you.
Yeah, sure.
One user asked, what are some of the issues doing this with ORD instead of SS3, SS4, or SS10, whatever you're using now, Mike?
I don't think any. Honestly, the main issue with ORD that you're going to notice, it's a 64-bit application versus a 32-bit, which is what this platform is. Essentially, what you're going to find is with that new application, it's probably going to run better, probably going to run more stable than this older application. But the interface is completely different. There is not this task toolbar that is there. Everything's ribbon driven. Looks very much like Word and Excel nowadays with the big ribbons on top. Probably looks a lot like if there's Civil 3D users on the Horn, then they're probably going to have a little more familiarity with that than even I do at this point. So
yeah, okay, that's a good response. And yeah, like I was talking with Mike earlier, a lot of these tools have been carried through to the Connect edition, which I think is what the user was asking about with ORD, because this is still ORD technology that Mike has just demonstrated, but it's been revamped a bit. So like Mike was saying, it's a lot faster. And there are changes to the interface itself, which I think a lot of people, anybody who uses the Connect edition, has kind of seen that. The ribbon is very, very big, so that's one difference. I have another question here. Are there 2 centerline alignments or 4 for each leg of this roundabout?
okay, so that's more of a roundabout question, and that's a good question.
Right.
It depends on your vertical need. So typically you would have a single center line that would come all the way through your project east to west, but it's not, your roundabout's not going to be, symmetrical in the sense of a standard roadway. You may have your right edge of pavement in the median, for example, come left of your center line for a bit, depending on the curvature you need to provide in order to control speeds appropriately. So from a purist perspective, on the roundabout side of things, it'd be nice if all these were done with a perfect intersection geometry where you could come in with very little deflect without having to really bow out a road like we did on this side here. And I'll pull the aerial back in, that may help. But you would have 2 center lines, north, south, and east and west for each corridor. But I would tell you, likely once you got into the grading side, and I know that wasn't part of this call, but you would probably have one profile grade line for the right and left at each of these locations. And once you get into using ORD, then you have a whole lot more control of your profiling than you do in the current environment, because as you lay out your profile along that center edge, you can run a pavement component with an in condition on the outside to see the results of your decision making on the vertical side dynamically. So if you run a profile along this PGL right, for example, and you're impacting an adjacent property too much, you may have to raise or lower that grade line in order to get your toe slope out of that property, or to minimize rather the influence in that property. So you'll be able to see that dynamically as you change your profile grade. But again, I know that's outside the realm of this conversation, but essentially you would have probably a PGL right and left for all of them, with the exception of this side over here. That may just have one, but this is likely going to have a different vertical than this.
Okay, thank you, Mike.
Yep.
Let's see here. There was another question. I'm not going to read the entire question, but I'll kind of try to summarize it. One user had asked if anyone has used Transoft's Roundabout design software, Taurus. And Mike, I guess I'll direct that to you. Have you used that? Do you know anything about it? And if
I've heard of it, and I've seen demonstrations of it, but I have not used it.
Right.
And my understanding is they're trying to get it to a point where it'll do everything for you.
Right.
With my experience with roundabouts, and I've laid out a good bit of them, but not as many as some of the folks I know in Kimley-Horn that are hopefully on the phone today too. Most of the people I know that have done a lot of roundabout design, it's just not a software that can figure all the geometry for you. It's too cumbersome. It's too much back and forth. It may be good to get a concept together, but no intersection is the same. All intersections are different. So, you can see this one here. I tried to pick an intersection that ultimately is going to be a roundabout. It's going to be a 1x1. It's not a 2x1 in reality, but I wanted to show something that was for existing geometry for a roundabout intersection, and how you would work with it. I didn't want to select something that was perfect for the demo, right, because I wanted there to be issues, because there's going to be.
Right. Yeah, I've got a good amount of experience with roundabout design, and that's kind of the same way I've seen it. It probably works really well with something like a T intersection, something that's, a perfect classroom environment setting for a roundabout, where it's a T standard intersection where everything kind of lays out perfectly. But I'm not so sure about how well that works. That leads me right into a follow-up question that another user had, and that was, I think what the user was asking was whether or not you've had any experience with ORD roundabout civil cells at all, and what are your thoughts on them?
Our friend Vern Danforth watched me do a demo similar to this, but with 3D design as well, and he said he thought I was pretty close to coming up with a civil cell, but I've played around with the idea to do it. There's just too many moving parts. You can come up with a civil cell that'll work for a specific intersection, and that specific intersection, that civil cell that you use for it's unlikely it's going to be usable at a different intersection.
Gotcha.
I just think there's just not always going to be the shortcut. It'd be nice to a degree. I kind of like doing it myself anyway, but
right.
Yeah.
I was looking roundabout. I always look at roundabout design as kind of more of an art form almost. It's very difficult to just package into some, equation that right. The majority of the work we do is that way, but roundabouts are it's a different animal.
Right.
All right. Does anyone else have any questions? They could either raise their hand with the hand icon, or they could type it in and I can read it. Also, I think Mike has agreed that he would stay around for a few minutes after one, and take, if there's some people that really have some questions that we can just get on in a smaller scale, get on to more of a one-on-one with some questions for Mike. His time is limited today. He's got some meetings coming up, but I think he could probably field a few questions if people would like to hang on after we're done with this initial Q&A session. So if anybody has any questions right now, go ahead and shoot them off, and I think Mike will try to field them. And if not, I think he agreed that he could hang on for a few minutes and ask any, people want to ask him some more direct questions that might work.
So I do see a question about NYDOT with different vehicles, swept path analysis inside minimum radii. I default, and most of my colleagues and people who've tutored me up on roundabout design, we default to the NCHRP document. FDOT locally has more guidelines regarding the types of vehicles they want to see, but it's really intersection specific. And it's really going to pertain to the type of volumes and users that you have at any known intersection. And the reality is you may not have to provide all turning movements for a larger tractor trailer. For example, on this corridor, the east-west traffic has very infrequent, if any, large truck via movements, but the north-south through movements have to accommodate the larger vehicles. So all that plays, you have to take it all into account when you're vetting your swept path. And FDOT has a requirement that the wheel path has to be offset at least 1.5 foot from the face of curb. So as you're running your design vehicle through the roundabout, your wheel path really needs to stay on the lane line, because if you're using a type F curb in the median, at least here in Florida, there's a 1.5 foot gutter pan to the face of curb. So if your wheel path is on or inside the lane, on the lane line or inside the lane, then you've got the appropriate clearance. But each DOT is going to have its own nuances or preferences in that regard. Likely, I'd say.
All right. All right. Well, I'm going to just one more time. If anyone has any questions, go ahead and shoot these off. And if Mike, if you have any other last minute things that you'd like to go over, you're welcome to do so. A lot of people are telling me you're doing a fantastic job, and they really enjoyed the presentation.
I appreciate it. Hopefully it wasn't too boring. I know it's a lot of rinse and repeat. It's a lot of the same relationships built over and over again, but it does take a little bit of time to get used to the new interface and using these tools versus the regular microstation line work. It just takes time to get used to. So my recommendation is everybody dig in, because it's coming. And once we get into ORD full time, regardless of what DOT you're with, this is the future of microstation and design. So
that's a very good point. All right. Well, thanks, Mike. We hope everybody had picked up a little something they can use. If you have any questions that you'd like to hang on to for a few minutes, I think Mike has agreed again to take a few questions discussion with a smaller audience. Just a reminder, we will send out PDH credits to attendees, but please contact events at nclug.com. If you don't receive a credit receipt, if you use the forwarding link, you must go to the nclug.com website and register to get credit. Stay tuned for next week's Tech Talk, and you will get an invite soon. If you have a topic you want to be covered, please email events@nclug.com. Now, be sure to tell others to become NCLUG members. It's free, so they can get the invites for upcoming events. NCLUG is looking forward to start planning for 2021. If anyone has an interest in being on the NCLUG board, please send us an email at events@nclug.com. Patty, do you have a drawing for the winner, a name drawn for the $50 Amazon card yet?
Yeah.
Looks like Justin Davenport.
Nice.
Yep.
All right.
I'll take 10% of that, Justin. Just saying.
We'll send it your way,
right.
Mike. All right. Well, thanks everyone for joining us today. Look forward to next week, and have a great day.
All right.
Mike,
thank you all.
Are you going to stay on the phone for just a few minutes, and let's see if there's some questions?
I will. And
Okay,
if this is
great.
still being recorded, if at all possible, what I'll do is I'll let me just add here my contact information. So if anybody wants to email after, is that appropriate or is that not appropriate?
No, that's, I think that's fine.
That's fine.
Should be.
I intended to do that earlier on. So this is me. That's my email address. So anybody has any follow-up questions, as long as it's not too overly complicated or takes too much time to address, I'll be happy to answer any or have any further discussion. So that's my contact information. Feel free to write it down. There's a lot that have already logged off, but if they watch the presentation later, maybe it'll provide some insight, or I can help out.
All right. Did anyone want to just now we're running, we got a few minutes here. If anybody wants to just raise their hand and ask a question, or just speak out. I'm not, Patty, how does that work? If we want to just open this up a little bit now for folks to just ask some questions to Mike.
Yeah, they can just unmute themselves.
Okay. So if anybody has any questions, go ahead and shoot.
So while folks are thinking up questions, Patty, just so that you know, at some point in the near future, as North Carolina gets closer and closer to embracing the 3D design technology with this stuff, I'll be happy to provide any demonstrations of that as well.
Yes, I'll definitely be getting up with you, Mike, after the call. This is a very good, it was very informative. So I'm not, it doesn't look like we're getting any more additional questions. I'll just say one more time, if anybody has any other last minute questions, please go ahead and you just unmute yourselves and ask Mike. He'll be on a call for just a few more minutes, unless it gets into a very deep conversation.
Mike, this is Jim Reed here with Gradient in Fayetteville, North Carolina. Thanks for the presentation.
You're welcome.
I had a quick question regarding when you get into the vertical component of it, when you're setting up your alignments and your templates, and then you have what's the best way to model that roundabout? Is that simply an exercise in grading? Is that template? Is it linear templates? What is there a good workflow to work off of in that regard?
I think what you're going to find is it's going to be a combination of all of the above. So obviously for the approaches, coming back where you have what looks more like a typical section that's going to be represented in your plan, where you have pretty symmetrical lane assignments, your medium may vary or whatnot, you're going to run a template to address most of that with flexibility in the cross slope built into your template, whether it's a parametric constraint or you're using super elevation shapes or outside edge of pavement profile, what have you. But you're going to run a template up to the point where it just doesn't seem, from a designer's perspective, to make sense anymore to run a template. At least that's the way I've done it. I designed a partial 3-lane roundabout for the city of Sarasota. It was a FDOT project in District 1, US 41 and Gulfstream. It's actually getting let in about 3 or 4 weeks, I think. But to do that grading, I ran the template as far as I could. And once my island areas, it just didn't seem to make that much sense to run a full template on the left and right. You can divide it and create a template for one side of the road versus the other. And I would do it with left and right. I would not run a template on my PGL right as a linear template because you have less flexibility with overriding parametric constraints. And I like to use the parametric constraints for cross slope and lane widths and things like that. So I want that flexibility. So I will run it as a corridor. So your template has to be set up to run either on the right side or the left side, depending on the direction of your alignment. And as I get into the roundabout, for the most part, in these areas where your road comes into the circulatory roadway, it's just profiling lines. And
Okay.
then once you have your lines profiled the way that you want them, you'll run linear templates to fill in the voids for your median curb and probably triangulate your last little piece of sod in the median from back of curb to back of curb. And then you could run a component of pavement that'll have your asphalt and base and stabilization depths assigned to it from the inside to the outside. But all the vertical control, at least what I've done in the past, has been just by profiling the lines and then grabbing all that and triangulating it, providing depth.
That makes sense. Thanks.
Mike, so I got you on the call. I got a couple questions for you as well.
Okay.
Now that I think about it. So yeah, you got your standard templates that run up until, like you said, you get off and you're like, okay, this template no longer is really applicable anymore. It's just getting kind of crazy. So you're saying that what you're doing, and this is what I had traditionally done with SS2 when I was modeling roundabouts, was I would use like a template that handled each quadrant, like a left and right. Is that what you're saying that you do? Is that how you're currently doing it now, or?
I mean, it really depends on what your typical section is. So I have a 2-lane section here.
Right.
And this lane may have a different cross slope than this outside lane, depending on my grades, right? And if you're in a curb and gutter facility, you have a longitudinal grade on that outside that you have to adhere to per criteria. So if 2% makes sense for this inside lane, but this has to warp over to a 3% at times to achieve the grade along your curb line that you need, then this template may need to have single lane flexibility from a cross slope perspective. Whereas this side, you may not need that. You may just be able to do one piece of pavement all the way across 24 feet wide.
Right. Just like you were saying, every intersection is different. So it depends on the scenario.
Yeah. And I've had roundabouts, did a couple roundabouts for the city of Naples, and there were smaller scale single lane roundabouts, but it was in such a tight area that was constrained by right of way, and the vertical was really challenging. I didn't run any corridor templates on the road at all. Everything was what I call detail modeled. I would take the line for the interior and profile it, the line for the exterior, profile it, and I would just have a lot of cross slope lines or lines that I would draw from inside to outside edge of pavement, and I would check the cross slope of those by targeting the 2 profiles, making sure I was within tolerance, and just let the cross slope be the one thing that varied the most. And there are times where you may control the outside edge by forcing a 2% here, 2.5% here to 3% here, and then look at your profile view for that outside edge and target each one of those cross slope points and let your cross slopes dictate that outside profile. It really is very project specific. There's no blanket answer other than you've got to evaluate each line independently.
Right. Have you done anything as far as the circular movements for the vehicles in the roundabout? Have you ever just basically laid out the center island area with the truck apron and everything, and then used a terrain for the pavement based on your like a linear template for the outer curb and gutter as it runs around the intersection? Or have you used?
That's almost exactly what I do. So when I say detail model it, I'm creating 3D brake lines for all of those lines interior, and then I'll grab those 3D brake lines and triangulate them into a terrain, and then apply a surface template to give it the pavement depth for my typical section. And then I'll run a linear template on the inside for my truck apron, because that's pretty consistent.
Yeah. Right? Do you do a linear template on the outside of the intersection too? Basically, like if you were to be running up in your right EOP or your right edge of travel there, right? Would you run a linear template along that over to the other leg of the intersection?
Yeah.
Does that make sense?
Likely.
Okay. So you basically, sounds a lot like that. That's what I was kind of thinking might work. Would be, I haven't done a lot in SS4 with roundabout modeling, but I was thinking if you run a standard template in a normal section, then once you get in there, then you start using some linear templates to kind of handle some of that stuff. And then that's good. That's really good information.
I would likely have a template for the right side of my road, excluding the median, that would run along this PGL line up to this point, and it would stop.
Gotcha.
And then I would have a surface between those lines.
Gotcha.
Right?
Yes.
So that void that's created in here would require its own surface, because then I would not.
Right.
This is probably where I would begin another template on this PGL right, moving to the right, to the east. So this would be a corridor. This would be a corridor. This would be a surface. And then this area in between, this odd little area, would also be a surface, which would require me from here, from here to run an edge template or a linear template to complete that edge condition. Unless I'm doing something weird, like if I have my sidewalk coming out and it's coming way out here to cross, I may just run a template for my curb and then detail model my back and front of sidewalk points, triangulate that, give it depth, and then just fill in the void with another triangulated surface for sod.
Gotcha.
So I wasn't prepared to discuss 3D too much. Otherwise, I would have copied over the model from the Gulfstream project and opened it up and showed some folks, because I think that would shed a little more light on how
Now,
I had a feeling 3D was going to come up today, though.
Yeah. No, you did excellent, great, man. It was a very good, very informative. As a Roundabout geek, I absolutely enjoyed the presentation. So I think, and I was amazed at how well you just kind of on the fly did this. I've done presentations live, and I hate doing them because you never know what's going to happen. So props on that, man. You did good.
I always expect to get kicked out of MicroStation 1, so I was happy.
Right. I could tell. you mentioned that. I'm getting ready to get kicked out. Well, we appreciate we appreciate that, Mike, and I appreciate everybody getting on the call today. Again, we hope you guys learned or got something out of this. Like Mike said, you can reach out to him personally if you have any more additional questions. If anybody has any last-minute questions, this is the last call, and then we're going to jump off here, and I'll just give it a minute here. But thanks, Mike. We appreciate it, man.
Yeah, absolutely.
Very good.
My pleasure. I really appreciate the invite. So thanks for setting this up, Jason and Patty. I appreciate all your efforts with NCLUG, or however you all say that. FLUG is so much easier than
we do NCLUG. Yeah.
It gets mixed up sometimes with I think NCLUG, doesn't it get mixed up with Legos or something like that too?
Yeah, there's a North Carolina Lego user group.
Right. And there's a little mix up.
There's a Lego user group.
There's a Lego user group, man. So
I believe.
Anyway. All right. Well, I appreciate that, everyone. Thank you, and have a great day, and we'll talk with everyone next week.
Thank you.
Thank you,
appreciate it.
Bye.